Today's lesson talks about using properties of special pairs of angles. So the first little thing we got to do is we got to understand these theorems. The first one says right angles congruence theorem. It says all right angles are congruent, and you could just put the congruent symbol if you'd like. So go ahead and do that. The congruent symbol. That's a good fast way to write congruent. So this is pretty obvious. Anywhere I have a right angle, doesn't matter where, even in this little box. If I have right angles, if they're right angles, then they're all congruent. The next one says write a proof. So we got to look at this one carefully. Example 1, it gives us a bunch of information. It tells us what we're trying to prove. The first thing we got to do is analyze the given information. It says JK is, what's that symbol? Perpendicular. JK is perpendicular to KL. And let's see if it's noted. Yeah, it's noted by that right angle mark. They then say ML is perpendicular to KL. ML perpendicular to KL? Yes, they have the right angle mark. That means their given stuff is marked on the picture. That's good. That's what you always need to verify. If they didn't mark it, it's your job to do so. The last thing we're trying to do is prove the angle K is congruent to angle L. So remember, that is always your last statement. Typically, what's your first statement? The given. And just double check. Does this stuff match the given exactly? Yes. So that's our given statement. The next thing we got to do is we got to fill in statement number 2. It says we're going to use the definition of perpendicular lines. If you don't have that one written down on your list, you might want to write it down in the margin of your paper. That's another reason that we can use. Do we have that one already written down? Yep, we already have that one. Good. So definition of perpendicular lines. What's it mean if two lines are perpendicular? They intersect to make a right angle. They intersect at a 90-degree angle. So what pieces or what 90-degree angles are made in this picture? How do you name the 90-degree angles in the picture? K and L. Let's use 3 letters. That's even a better name. So angle J, K, L. We're not going to say they're congruent yet. We're going to say measure of angle JKL is how big? 90. If it's perpendicular, it means it makes a 90-degree angle. Also, we can say the measure of angle MLK is 90. Now, you can use the single letter name like they do. You can, but I want you to really practice using 3 letters because it's definitely more specific. It's a better name. Why are they able to go from statement 2 to statement 3, though? Yeah, go ahead. So real quick, we should discover that these two 90s are consistent between those 2 terms. So really, I would take 2 optional answers. Since these 2 are the same, we could cut the repeats and write what's left. But what they do is a little bit better. They talk about substitution, I'd say, was a good reason. A lot of you said that. But I would also take transitive on that one because they're exactly the same on the 90s. That would be a good one. In definition of perpendicular lines, we could also, this is good, let's leave it there. On these next theorems, it relates back to some old topics we've discussed, complementary and supplementary angles. First one says congruent supplements theorem. Basically, all it's saying is if these angles are supplementary to each other, and these angles are supplementary to each other, then these 2 are congruent to each other. Now go back through that one again. If 1 and 2 are supplementary, and 2 and 3 are supplementary, then 1 and 3 are the same. So we should be saying then they are congruent. So if 1 and 2 are supplementary and 3 and 2 are supplementary, then what did I say? 1 and 3 are congruent to each other. Same kind of thing for complementary. If these two over here, 4 and 5 are complementary and 5 and 6 are complementary, then 2 of them are the same. Which ones are the same? 4 and 6 are the same. So they're congruent. So 4 is congruent to 6. Good stuff. On example number 2, it says write a proof. It gives you a bunch of information. We're trying to prove that last statement, that measure of angle 4 is 45 degrees. Let's do the easy stuff first. What do you all think is the easy stuff? Given. Where should I write the word given? Number 1 reason I heard. Is there any other spot to write a given? Oh, measure of angle 2 is 45. That's also down here on number 4. There are 2 givens. I separated these up here into 2 statements. A lot of times we need to make sure that our given information matches what is drawn in the picture. Let's do that. 1 and 2 are supplements. Yeah, they add up to 180. 1 and 4 are supplements. 1 separated from 4, but I could see how they still add up to 180. And they say angle 2 is 45. Do they have that noted on the picture? No, so let's write that in. That angle right there is 45 degrees. It's a given, so we can write it in there. Now we're trying to prove that 4 is 45. So we're going to walk through our proof and show step by step how it logically works out. First thing, it says use the congruent supplements theorem. Well, congruent supplements say if 1 and 2 are supplements and 1 and 4 are supplements, then what pieces are the same out of these? 2 and 4 are congruent to each other. They're both congruent to 1, so they're congruent to each other. Sorry, they're both supplementary to 1, so they're congruent to each other. Now what do? 2 to 3. This next one, there's only one option. What do they do on this one? Yes, you got it. So this one is that little silly one. So it goes from congruence to equals. It still says the same angles. It just goes from congruence to equals. And what's that one called again? Definition of congruence, we'll say. Definition of congruence. So you should recognize that one. That's the silly one that doesn't really do anything other than change congruent to equals or equals to congruence. But now they change stuff up. They go down and say, angle 2 is 45. It's a given. That means I'm probably going to be using this to generate the last little statement. It says I'm supposed to use substitution. What are we trying to prove in the end? What are we trying to prove? Guess what? They gave you the answer. But you need to understand why that's true, because it's not always going to be this simple. Why can they say this last statement? Obviously, we have it from our stuff in the beginning, but why can we say this one over here? So I just heard that these are going to be used to make this one. Let's see how that works. Anywhere I see measure of angle 2, I can insert measure of angle 4. Hey, what? Guess what? Right there is measure of angle 2. I can replace that one with measure of angle 4. That's exactly what they did. They replaced one term. They replaced it, so that's called substitution. That's a good proof. That's a good one for the test. On these postulates, it says if two angles form a linear pair, then they are supplementary. Good job. Good job. Then they are supplementary. What supplementary mean? They add to 180. Add to 180. Also, it says 1 and 2 form a linear pair, so 1 and 2 are supplementary. So angle 1 plus angle 2 adds up to 180. So we already said that. That's pretty easy. Vertical angles. This is a good one. Vertical angles. Vertical angles are always congruent. So I'm going to show some little pictures that help you remember these things. Linear pair. Linear pair. What's pair mean? 2. It means you can take two angles, and if you draw them so they're stuck together, they should form a straight line. That's a linear pair. Is this picture a linear pair? They make a straight line. It's not a pair. It's not two angles. It's actually 1, 2, 3. This is not a linear pair. That's a bad example. This one right here is a good example. The key thing I want you to get from this is it's okay to have a bunch of angles making a straight line. You still know that angle 1 plus angle 2 plus angle 3 is 180. But you're not going to be able to say that they're a linear pair because it's not a pair of angles, not just two angles. The next one is vertical angles. I have a cool way of remembering this one. Vertical angles are always formed by a perfect X. I would definitely draw this. Always formed by a perfect X. Sometimes they'll add in some other lines here and there. And if I come through and number these, 1, 2, 3, 4, I have 5 angles there. Only a couple of them are vertical angles. Vertical angles are congruent. Which ones look to be congruent in that picture? 2 and 4. And I heard 1 and 3. Well, let's look at 2 and 4. 2 is right here. 4 is right here. What letter is this in the alphabet? What letter is this in the alphabet? Vertical angles. Those are vertical angles. They're the same size. They're across from each other. They're formed by a perfect X. However, I heard some people say 1 and 3. If I extend these over, here's 1 and here's 3. Is that a perfect X? Are these exactly the same size? No, because that little 5 was inserted there. 1 and 3 are not vertical angles. Which ones are vertical over here? Okay, so write that out to the side. Angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. This is stuff you have to know. We're going to use these ideas all year long. Probably some of the most important things you're going to learn all year long is right here on the board right now. All right, here's another proof. Example 3. It says angle 4 is a right angle. Is that drawn on the picture? Yes. We're trying to prove 2 and 4 are supplementary. What's the easy stuff to do on this proof? Given. Where should I mark my given? Reason 1. I make sure it matches. Yes, it matches exactly. My given goes in reason 1. Are there any other given statements in here? No, it didn't tell us anything else in this given statement. There's something else that I could write, and that deals with the prove statement. Where's the prove statement going to end up? At the very bottom down here. So I should say angle 2 and angle 4 are supplementary. There's some easy points. Those are easy. All right, I'm going to start back at the beginning now. So from the beginning, we had angle 4 is a right angle. Well, if angle 4 is a right angle, how big is it? 90. Its measure is 90. That's easy. That's called the definition of a right angle. You should have that drawn somewhere, written somewhere. Now it says angle 2 is congruent to angle 4. 2 is congruent to 4. Why can we say 2 is congruent to 4? Those are vertical angles. And I'm going to put VA. I'll allow you to do that all year long. VA, vertical angles. From there, we see that we're going to be using the definition of congruent angles. Definition of congruence. What's that do? Oh, that's the silly one. Changes congruence to equals. Measure of angle 2 equals measure of angle 4. Very easy. All right, now they conclude this down here. Why can they conclude number 5? It's based on some previous information in the earlier steps. This is going to be substitution. You should start recognizing these really fast. So that's substitution property of equality. Where does this come from, though? What 2 statements did they use? What statements? It's not 3, because 3 doesn't have equals. It's 2 and 4. 2 and 4 make number 5. What they say is angle 4 is 90, but down here we say anywhere there's an angle 4, I can replace it with an angle 2. And that's what they did. Done. Good job. All right, these down here should be pretty quick and simple. First thing you got to do is read what it says. Angle 4 is 63, so I draw it in there. Angle 4 is 63 degrees. Find angles 1 and 2. Well, out of angles 1 and 2, which ones are the easy ones? 2. Well, how big is 2? Yeah. Why is it 63? They're vertical angles. Good. But how do you find the ones right beside it? Okay, so I get these others by subtracting 180. So I'll get angle 1. Measure of angle 1 is found by doing 180 minus 63. And what do you get there? 117. So there's angle 1. We already found angle 2 is 63. Those are our 2 answers right there. Now they change it up a little bit. They say, all right, we're going to change the numbers. Angle 3 is now 121. Which one is the easiest in the picture? Angle 1's how big? 121. Why? Vertical angles. And then the ones right beside them. How big do we find those to be? 59. How do you get 59? Okay, so subtract from 180. So that's pretty simple. Good job. Here's the last one we're doing. This is definitely on the test, on your homework tonight. Some people freeze up on these on the test for some reason. I don't know why. But this is generally where we can tell that some people did not study and didn't ask questions. What we're going to do here is read carefully, understand what's going on, and go from there. We're going to write and solve an equation to find x. Here's x. We're going to use x to find the actual angle. So we're going to follow these steps and go from there. First thing you got to do, locate the angle. It's right here. And what other given information did they draw in the picture? Yeah, GKH is 113. Those are the 2 angles I'm given. I got to determine, are they vertical angles or linear pairs? Linear pairs, this is how you should always set up a linear pair when you're doing equations like these. This is like a little formula for linear pairs. Once again, I said that wrong. Linear pair always adds to 180 degrees, not 90. So we got to now substitute those values in the picture into these blanks. So the first blank we'll say is 4x minus 1. What's going to go in the second blank? 113. Now it's some simple algebra. I can get rid of my blanks so I don't confuse them with division. Now when I take that value for the x and substitute in to find FKG. Well, here's FKG. That's at 4x minus 11. So I'd write that out. Measure of angle FKG equals 4 times, substitute the value, then minus 1. When you type that in, you should get your final answer. 67. Okay, try that out. Double check that. That should be the correct answer. All right, here we go. The first thing you should realize, you should always be thinking about vertical angles and linear pairs. We just did a linear pair a second ago, and the formula for that was blank plus blank is what? 180. 2 things added together is 180. But vertical angles has a different kind of formula, if you want to think of it as a formula. What do we know about vertical angles? They equal each other. So basically you're setting 2 things equal to each other. Are these vertical or linear pair? They're vertical, so basically I'm plugging into my blanks over here. 4x minus 18 equals 3x plus 4. From here we're solving. Let's get our x's together first. What x should I move? Why do I move the 3? That's the smaller one. Last step. Add 18 to each side and we get 22. But does that answer the question? Find the value of x? No, we got to plug it in here for AEB. AEB is over here. So measure of angle AEB equals 4 times 22 minus 18. Do that math and you get 70 degrees. Good job.